Hello. Today we're going to be learning about moles, the Avogadro's constants, molar mass, and the molecular mass. Okay. So, let's start off with what is a mole. So, a mole is a substance, is the amount of substance that contains as many particles. So, for instance, in this, you see this is the basic formula that all chemists should know because this is H2O, very common. It is water. So now, if I were to say, I were to ask how many moles of oxygen is in H2O, the answer would be 1. Now, to find this, you just have to find the number in front of it or the number around this area, you see? Sorry. I think it's called subscript. It has to be either in the subscript or as you call it, like a number in front of it. Okay. Next. Okay. So, 1 mole is essentially equivalent to 6.022 times 10 to the power of 23 particles. Now, this is actually something very important. Make sure that you, I guess, engrave this in your mind because when like calculating a bunch of stuff, you essentially require this. Like, it's yeah, it's used to telling us like how much of a substance we have. Okay, and here's a fun fact actually. Oh, sorry. The Avogadro's number was obtained by dividing the charge of a mole of electrons by the charge of a single electron, which is equivalent to that this value here. Now, you don't need to know what this is about right now. It's not really that necessary. You can, I guess, learn about it when you get, I guess, higher level. It's just a fun fact. Even I didn't know how they. I didn't even also know how they obtained it. This is kind of new to me. Okay, now question time. How do we find the mole of a substance with an assigned mass of x grams? Okay, so um, here's one a mole. Okay, a mole is essentially equivalent to the mass or the molecular mass. Now the mass is like the, for example, in the question, if they say, "I've given you 2 grams of H2O," well, if they say grams, it's mass. Okay, now, if it's for molecular mass, to determine that, you have to add up the atomic mass of um, the H, the two H's and the one O, and that gives you the molecular mass. Molecular mass is often given in like grams per mole or AMU. Okay. Now, this value here, um, the what we do here is we use this um, formula to find the amount of atoms or molecules in a a a gram of some kind of, like, for example, they have like 4 grams of H2O, and we use that Avogadro's constant to find the amount of molecules or atoms in that substance or in that X amount of grams. So it's basically going to be like um, mass over molecular mass, um, like how can I explain this? Wait, let me just find this. Uh, wait, how can I explain this to you? Okay, I'll just use this as an example. Okay, so here's the mass and here's the molecular mass, if I'm correct, and yeah, molecular mass. Now, um, we multiplied this by the Avogadro's constant over the 1 mole because we know that 1 mole is equivalent to that. And if you're trying to find the amount of atoms or molecules in that x grams, we have to make the mole as the denominator here, so we can cancel out the moles, because after all, we are in this case, like if they ask how many atoms are in this x amount of grams, then we have to do that. We have to cancel out the moles and turn it into particles, atoms, or molecules. Okay. Uh, yeah, and I think okay, I'll just go over this here again. So yeah, if they ask here like um how many moles is in like 5.69 grams of NaOH, you have to just use the mass here, and then you have to first find the molecular mass, which is the added value of all the elements in that specific compound. So if it's H2O, then it's going to be like um, the the molecular mass here would be um, 2 times the atomic mass of hydrogen added with 1 oxygen, like the atomic mass. Okay, which you get like I think 18.02 grams per mole, something like that. Um, yeah. Now the as I said, the molecular mass unit is grams per mole, right? So when we have G at the top, and then if it's like G over grams per mole, then the G's will cancel, and the mole will remain, which is why mass over molecular mass is, or molar mass is equal to moles. You can use the units to also like explain it. Okay, here's another question. I'll be asking you also the percent mass of like some element in some, I guess, compound. So for example, how much percent mass of oxygen is in H2O? So as I said earlier, H2O, the molecular mass of that is 18.02. Okay. Now if you want to find the percent mass of oxygen here, right? You have to essentially use the mass of 1 mole of oxygen, because in this case, um, the oxygen has no number in front of it or as a subscript, so that means it has 1 mole. Okay, so to find the percent mass here, we have to use the total or the molecular mass. Sorry, it has to be like the mass, molar mass of oxygen, no, atomic mass of oxygen over the molecular mass of H2O, and we use that to find the percent mass of oxygen. Here are the calculations, and well, yeah, you get a decimal and you have to multiply it by 100, and then you get the percent, and you can, I guess, um, what's the word? Simplify it. No, estimate. Sorry, you can just estimate it, and you get about like um 8 point, sorry, 88.8%, something like that. I don't know. Um, there might be some instructions, maybe like in some questions that they say like round it to this amount of digits. So you gotta watch out for those. You shouldn't just carelessly round it off. So yeah, okay. I'll be giving you the questions. Hope you do well. Goodbye.